March 15, 1946. A cluttered laboratory in Leo Minster, Massachusetts. Earl Tupper stood hunched over a workbench, his calloused hands molding a translucent bowl that would revolutionize American kitchens forever. The 44-year-old chemist had spent the previous decade perfecting a material that everyone else considered industrial waste. Polyethylene slag, the black, oily residue left over from petroleum refining, had been dismissed by every major manufacturer as useless garbage. Yet here, in a converted DuPont factory building, Tupper was transforming this unwanted byproduct into something extraordinary. The bowl in his hands possessed qualities that seemed impossible for plastic of that era. It was flexible yet durable, translucent yet strong, and most remarkably, it created an airtight seal with a distinctive burping sound that would become iconic across America. What none of the established manufacturers understood was that this discarded petroleum waste contained the key to solving every housewife's storage nightmare. Food spoilage, broken glass containers, and messy spills had plagued American kitchens since the dawn of civilization. Tupper's revolutionary plastic bowls would eliminate these problems, while introducing capabilities that traditional storage methods could never achieve. The mathematics of domestic efficiency were being written in polymer chemistry, revealing innovations that would transform not just food storage, but the entire concept of home organization and food preservation. The journey from industrial waste to household necessity began in 1938, when Earl Tupper accepted a position as a chemist at DuPont's Leo Minster plant. The facility specialized in manufacturing plastic components for military applications, producing everything from gas mask lenses to aircraft canopies using newly developed synthetic materials. Tupper, a former tree surgeon and failed inventor whose previous ventures had included landscaping, farming, and designing a fish-powered boat, brought an unconventional perspective to industrial chemistry. While his colleagues focused on established applications for proven materials, Tupper became fascinated by the possibilities hidden within manufacturing waste streams. The black slag that accumulated during polyethylene production presented a particular puzzle. This material, technically known as polyethylene distillate, resulted from the high-pressure polymerization process that created military-grade plastics. The slag contained all the molecular properties of polyethylene, but in a form that existing manufacturing equipment couldn't process effectively. Most companies simply disposed of this material as industrial waste, paying contractors to haul it away. Tupper saw opportunity where others saw garbage. Working after hours in the DuPont laboratory, Tupper began experimenting with purification techniques that might transform the black slag into usable material. The process required patience, precision, and dozens of failed attempts. Traditional plastic manufacturing relied on virgin materials with predictable properties. The slag contained impurities, inconsistencies, and variations that made it nearly impossible to work with using conventional methods. Tupper developed new approaches that embraced rather than fought these irregularities. The breakthrough came through a combination of heat treatment, chemical purification, and mechanical processing that Tupper perfected through countless trials. He discovered that by carefully controlling temperature and pressure during refinement, he could produce a polyethylene material that was actually superior to products made from virgin stock. The refined slag possessed a unique combination of flexibility and strength that made it ideal for applications requiring both durability and resilience. December 7, 1941. The attack on Pearl Harbor transformed American industry overnight, including the small-scale experiments taking place in Tupper's laboratory. DuPont's entire production capacity shifted to military applications. Plastic manufacturing facilities that had produced consumer goods now focused exclusively on wartime needs. Aircraft components, military equipment housings, and specialized chemical containers took priority over all civilian applications. Tupper found himself assigned to projects developing plastic components for military use, but his fascination with the potential of refined polyethylene slag continued. The war years provided unexpected opportunities for innovation. Military specifications demanded plastic products with performance characteristics far exceeding peacetime requirements. Components had to withstand extreme temperatures, resist chemical attack, and maintain structural integrity under conditions that would destroy traditional materials. These demanding specifications pushed Tupper to refine his polyethylene processing techniques to achieve levels of quality and consistency previously thought impossible. Working with military contractors, Tupper developed plastic components for gas masks, aircraft fuel systems, and naval equipment. Each application taught him more about the possibilities and limitations of his refined polyethylene. He discovered that the material could be molded into complex shapes while maintaining exceptional clarity. It resisted cracking under stress, remained flexible at low temperatures, and proved remarkably resistant to chemical degradation. Most importantly, it could be manufactured at costs far below traditional materials while offering superior performance. The military applications also taught Tupper about the importance of precision manufacturing. Military specifications tolerated no variation in dimensions, no defects in surface finish, and no compromise in performance. These requirements forced him to develop quality control procedures and manufacturing techniques that exceeded anything used in peacetime consumer goods production. When the war ended, Tupper possessed both a superior material and the manufacturing expertise to produce it consistently at commercial scale. As victory in Europe became inevitable in early 1945, forward-thinking manufacturers began planning for post-war consumer markets. The American economy would need to transition from military production back to civilian goods, but consumers would expect products incorporating the technological advances developed during wartime. Plastics represented one of the most promising areas for innovation. Wartime applications had proven that synthetic materials could outperform traditional options in durability, functionality, and cost-effectiveness. Tupper recognized that his refined polyethylene possessed qualities perfect for consumer applications, particularly in the kitchen. American housewives had struggled for generations with food storage problems that his material could solve definitively. Glass containers broke easily and couldn't create truly airtight seals. Metal containers rusted, dented, and imparted metallic taste to stored food. Ceramic containers were heavy, expensive, and equally prone to breakage. Paper containers degraded when exposed to moisture and provided no protection against air infiltration. The challenge lay not in the material's capabilities, but in designing products that would demonstrate those capabilities to skeptical consumers. Americans in the 1940s remained suspicious of plastic products, associating them with cheap, brittle items that broke easily and performed poorly. Most plastic containers available in 1945 were indeed inferior products made from low-grade materials using primitive manufacturing techniques. Tupper needed to create products so obviously superior to existing options that consumers would overcome their prejudices against plastic materials. The design breakthrough came through studying how traditional containers failed and engineering solutions that addressed each limitation systematically. Glass containers broke because they couldn't flex under stress. Tupper's polyethylene could bend without breaking while returning to its original shape. Metal containers corroded because moisture and acids attacked the material directly. Polyethylene proved virtually immune to household chemicals and food acids. Existing containers couldn't create reliable seals because rigid materials couldn't conform perfectly to irregular surfaces. Tupper's flexible plastic could deform slightly to create perfect contact around the entire perimeter of a container. The most revolutionary innovation emerged from Tupper's observation of paint can lids. These metal covers created airtight seals by forcing a flexible gasket into a precisely machined groove. Tupper realized he could engineer a similar sealing mechanism directly into molded plastic containers, eliminating the need for separate gaskets or complicated closure systems. The design required extraordinary precision in both the container rim and the lid dimensions. But his wartime experience with military specifications had taught him to achieve such precision consistently. By late 1945, Tupper had perfected both the material and the manufacturing processes needed for commercial production. His refined polyethylene could be molded into containers with walls thin enough to be lightweight, yet strong enough to withstand normal household use. The unique sealing system created airtight storage that preserved food freshness far longer than any existing container could achieve. Most remarkably, the entire system could be manufactured at costs that would allow retail prices competitive with traditional storage containers. The first Tupperware containers rolled off production lines in early 1946, representing the culmination of 8 years of experimentation and refinement. These weren't just plastic containers, but precision-engineered storage systems that happened to be made from plastic. Each bowl demonstrated capabilities that no traditional container could match, challenging everything Americans thought they knew about food storage and kitchen organization. Uh, the initial market response proved devastating. Hardware stores, department stores, and kitchenware retailers examined Tupper's revolutionary containers with polite skepticism that quickly turned to outright rejection. Store buyers accustomed to selling glass bowls, metal canisters, and ceramic crocks couldn't comprehend why customers would pay premium prices for plastic products. The demonstration of the airtight seal that created Tupperware's distinctive burping sound impressed exactly no one. Retail managers dismissed it as a gimmick designed to mask inferior construction. Woolworth's buyer examined the translucent bowls in March 1946 and delivered a verdict that echoed throughout the retail industry. These plastic containers feel cheap and look temporary. American housewives won't trust their food to something that appears so insubstantial. Glass has served kitchens for centuries. Why would anyone abandon proven materials for experimental plastic? The rejection stung particularly because Tupper knew his containers outperformed traditional options in every measurable category, yet appearances trumped performance in the minds of retail decision-makers. Sears Roebuck's housewares department conducted more thorough testing but reached identical conclusions. Their internal memorandum, discovered decades later in company archives, revealed the depth of retail resistance to innovative products that challenged established categories. Tupperware containers demonstrate adequate functionality, but consumer acceptance remains questionable. Plastic products carry connotations of cheapness and temporary use. Our customers associate quality kitchenware with substantial materials that convey permanence and reliability. These containers, despite their technical merits, fail to project the image customers expect from premium storage products. The rejections multiplied throughout 1946 as Tupper approached every major retailer in New England. Macy's, Gimbel's, Jordan Marsh, and dozens of smaller chains all declined to stock Tupperware products. The consistent feedback emphasized consumer psychology over product performance. Retail buyers understood their customers' preferences and knew that plastic containers, regardless of their capabilities, would gather dust on shelves while glass and metal alternatives continued selling steadily. By December 1946, Tupper faced a crisis that threatened to destroy his company before it truly began. Manufacturing costs for precision-molded containers with engineered sealing systems exceeded the production expenses of traditional storage products, but retail resistance prevented him from accessing the distribution channels needed to reach consumers. The superior performance that should have commanded premium pricing became irrelevant when stores refused to display the products. The solution emerged from an unexpected source. Norman Mead, a door-to-door salesman specializing in household products, discovered Tupperware containers at a small hardware store in Framingham, Massachusetts. Mead purchased several bowls for his wife, who had complained about food spoilage problems in their inadequately refrigerated kitchen. The performance exceeded every expectation. Leftovers stayed fresh for days longer than in traditional containers. The airtight seals prevented spills and odors. The lightweight plastic proved far more convenient than heavy glass alternatives. Mead recognized immediately that Tupperware's capabilities could only be appreciated through hands-on demonstration. The translucent appearance that retail buyers criticized as cheap actually allowed customers to see stored contents clearly. The flexible material that seemed insubstantial actually provided superior durability compared to brittle glass containers. The distinctive burping sound that retailers dismissed as gimmicky actually provided audible confirmation of proper sealing. Every feature that hurt Tupperware in store displays became an advantage during personal demonstrations. January 1947 marked the beginning of Tupperware's transformation from retail failure to direct sales phenomenon. Mead contacted Tupper directly, proposing a partnership that would bypass traditional retail channels entirely. Instead of convincing store buyers to stock unfamiliar products, they would bring demonstrations directly to consumers' homes where performance could speak for itself. The approach required rethinking every aspect of marketing and distribution, but offered the only viable path to commercial success. The first home demonstrations revealed the power of showing rather than telling. Housewives who would never have purchased plastic containers from store shelves became enthusiastic customers after witnessing Tupperware's capabilities firsthand. The demonstration typically began with a dramatic test of the airtight seal. The presenter would fill a bowl with water, snap on the lid, and turn it upside down. Not a drop leaked. Traditional containers couldn't pass this simple test, yet Tupperware made it look effortless. The flexibility demonstration proved equally compelling. The presenter would twist and bend containers to show their resilience, then drop them on hard floors to prove they wouldn't shatter like glass alternatives. The containers bounced back to perfect shape, undamaged and fully functional. Housewives accustomed to replacing broken glass bowls regularly could immediately appreciate the economic advantages of unbreakable storage containers. Food preservation demonstrations provided the most convincing evidence of Tupperware's superiority. Presenters brought vegetables stored in Tupperware alongside identical vegetables stored in traditional containers for identical periods. The difference was dramatic and undeniable. Lettuce stayed crisp, bread remained fresh, and leftovers showed no signs of spoilage in airtight Tupperware containers, while conventionally stored foods had already begun deteriorating. By summer 1947, word-of-mouth recommendations from satisfied customers had created demand that exceeded Tupper's manufacturing capacity. The home demonstration approach that began as a desperate alternative to retail distribution had evolved into a superior marketing method that educated consumers while building personal relationships between salespeople and customers. Women who might have been skeptical of aggressive sales tactics responded positively to demonstrations that solved genuine household problems. The success attracted ambitious salespeople who recognized the income potential of selling superior products through personal relationships rather than competing with established retailers. Brownie Wise, a single mother from Detroit struggling to support herself and her son, discovered Tupperware through a friend's home demonstration and immediately understood its revolutionary implications. The products weren't just better storage containers, they represented freedom from the daily frustrations that plagued every American kitchen. Wise's first Tupperware party in her Detroit apartment generated more sales in one evening than most retail stores achieved in weeks of displaying competing products. The social aspect of gathering friends and neighbors to learn about innovative products created an atmosphere of shared discovery rather than commercial pressure. Women relaxed in familiar surroundings among trusted friends proved far more receptive to trying new approaches than isolated shoppers examining unfamiliar products in impersonal retail environments. The party format also allowed for comprehensive education about Tupperware's capabilities and proper use. Retail customers purchasing containers from store shelves received no instruction in sealing techniques, storage principles, or maintenance procedures. Home demonstration participants learned not just what Tupperware could do, but how to maximize its performance through proper handling and care. This education translated directly into customer satisfaction and long-term loyalty. By autumn 1947, Brownie Wise had transformed her modest Detroit apartment into the nerve center of a sales revolution that would reshape American commerce forever. Monthly earnings from Tupperware demonstrations exceeded what most factory supervisors made annually. But more importantly, she had discovered principles that would influence direct sales for decades. The party system wasn't just selling containers, it was creating communities of women who shared solutions to universal household challenges. Wise's innovations extended far beyond simple product demonstrations. She developed presentation techniques that turned routine kitchen tasks into entertainment experiences. The famous Tupperware burp became a sound effect that generated laughter and memorable moments. Children attending parties with their mothers competed to create the loudest seals, transforming product features into a family entertainment. The containers themselves became props and performances that demonstrated not just functionality, but lifestyle improvements. The psychological breakthrough came through Wise's understanding of post-war American women's circumstances. Millions of housewives found themselves isolated in suburban homes, managing households while their husbands commuted to distant jobs. Traditional social structures had been disrupted by wartime mobility and economic transformation. Tupperware parties provided legitimate reasons for social gatherings that combined practical education with personal connection. December 1947 brought Earl Tupper face to face with the woman whose sales techniques were revolutionizing his struggling company. Wise had generated more revenue in 6 months than Tupper's entire retail distribution network had achieved in 2 years. Her Detroit operation employed dozens of salespeople who had learned her demonstration methods and were replicating her success across Michigan. The meeting between the introverted inventor and the charismatic saleswoman would determine Tupperware's future direction. Tupper arrived at Wise's apartment expecting to find a typical door-to-door sales operation. Instead, he discovered a sophisticated business organization that had systematized every aspect of customer interaction. Wise maintained detailed records of customer preferences, purchasing patterns, and satisfaction levels. She had developed training programs that taught new salespeople not just product knowledge, but presentation skills, customer psychology, and relationship management. Her operation resembled a professional sales academy, more than a traditional direct marketing effort. The demonstration Wise conducted for Tupper revealed capabilities he had never imagined for his products. She didn't simply show containers sealing properly, she created dramatic presentations that made each feature memorable and compelling. The flexibility demonstration became a durability spectacle where containers survived treatments that would destroy traditional alternatives. The freshness preservation demonstration became a scientific experiment that proved Tupperware's superiority through controlled comparisons. Most remarkably, Wise had developed techniques for turning product limitations into selling advantages. The translucent appearance that retailers criticized as cheap became a visibility feature that allowed users to identify contents without opening containers. The lightweight construction that seemed insubstantial became a convenience advantage for women managing heavy kitchen tasks. The plastic material that carried negative associations became a safety feature that eliminated breakage hazards around children. By early 1948, Tupper had made the decision that would transform his company from manufacturing operation to marketing phenomenon. He abandoned retail distribution entirely, focusing all efforts on direct sales through home demonstrations. The choice required restructuring every aspect of his business, from production planning to customer service, but the results justified the disruption. Sales increased by 300% within 6 months as the party system expanded beyond Michigan into neighboring states. From a cluttered laboratory in Massachusetts to living rooms across America, Earl Tupper's journey from industrial waste to household revolution proved that innovation often emerges from the most unlikely sources. His transformation of petroleum slag into precision storage containers demonstrated that wartime necessity could birth peacetime prosperity. The distinctive burp of sealing Tupperware would echo through decades, reminding us that sometimes the greatest breakthroughs come not from accepting conventional wisdom, but from seeing opportunity where others see only garbage.